So today I'm going to go over Module 13.4, which starts on page 611. And we are going to go over solving absolute value inequalities. And I'm going to kind of jump around here a little bit because we just did solving absolute value equations. I want to go on to page, I believe it is 614, yes, page 614. And I'm going to start with explain to, and then I'm going to go back to those other ones. And part of the reason that I'm doing this is solving absolute value equations is fresh in our mind, especially algebraically. So that's what I want to talk about first. So the first thing is to solve an absolute value inequality algebraically, you start by isolating the absolute value expression, which again is the first step that we did in 13.3. When the absolute value expression is by itself on one side of the inequality, apply the following rule to finish solving the inequality. And so if you remember from solving absolute value equations, we said that you would split the absolute value to be when x equals a and x equals negative a. So what I want to kind of talk about is, what if this was not an equal sign, and instead we were talking about an inequality sign? Well, just like any time we multiply or divide by a negative when we're solving inequalities, if I multiply this a by a negative, what do I have to do with that sign? That sign doesn't stay, that sign has to flip. And that's kind of what's going to happen here. Well, not kind of, that is what's going to happen here. And so the way that the book sets it up is it says, well, if you're talking about a greater than symbol, you're going to set it up as an or statement. And if you set it up, if it's a less than symbol, then you're going to set it up as an and statement here. But what's really happening is you're flipping the inequality sign when you set it equal to that negative a value. So I'm going to show you what that looks like using example A here. First step we do always is to isolate the absolute value. So I'm going to isolate this absolute value sign here by getting rid of that 15 and subtracting it to the other side. When I do that, 21 minus 15 gives me 6. And so what I'm going to do is I'm going to take that argument inside that expression 4 minus x, and I set it equal to the negative 6, which means I had to multiply that 6 by a negative. So what happens to my inequality sign here? It's no longer a greater than, but I have to flip it and make it a less than. Right, for my second statement, for my second one, I have that inside argument, which is 4 minus x, and I'm setting it equal to the positive of this. So since I didn't multiply or divide by a negative, I don't flip my sign. I'm still using the same rules that I used when I solved just a regular inequality. Now that we're talking about absolute value inequalities, we still have to use that same. When you multiply by a negative, you flip your sign. So now if I was solving, I would subtract 4 to both sides, and I would get negative x is less than, negative 6 minus 4 is negative 10. And when I divide by a negative, I'm going to get x is greater than, wait a minute, what happened to my sign here? Let's see. My sign was a less than. Oh, but I divided by a negative, so I again have to flip that sign. So anytime you multiply or divide by a negative, in fact, I'm going to write a little note to myself here. I'm going to write, when you multiply or divide by a negative number, flip the inequality. So that's all that's happening here. For this other one, I need to go ahead and solve. So I found x is greater than 10, or let's find the other one, subtract 4, and I get 6 minus 4 is 2. I divide by my negative 1, And, oh, dividing by a negative, right? We just talked about this. We have to flip this inequality. So it went from a greater than symbol to a less than symbol. And 2 divided by -1 is -2. So if I were to graph these, let's start with this statement here. X is greater than 10. I have an open circle, and I'm shading where the values are greater than 10. Right? Open circle because it's not greater than or equal to, it's just a greater than symbol. And now for this statement here, I have X is less than -2. Again, that's an open circle at -2. And X values that are less than -2 go to the left. So this is my OR statement. Right? They're going in opposite directions. We're not looking for where they intersect. We're looking for which values make this statement true, which is an OR statement in this case. The values could be less than -2, or the values could be greater than 10. Remember, it cannot equal 10 and it cannot equal -2. Those are open circles and are not inclusive. So for example, to B, let's see what this is going to look like. So I need to, again, first isolate my absolute value. Here's my absolute value. I need to get rid of this -10. Using my inverse operation, I'm going to add 10. And a -2 is greater than, a -2 plus 10 is going to give me an 8. And now my absolute value is isolated, and so now I can split it. So I need my absolute value to be, equal to the negative and equal to the positive. And how did I know that the -1 needed to go here? Well, I noticed that they flipped the sign here. And since you're multiplying 8 by a negative and you're talking about inequalities, you have to flip that sign. Over here, they did not flip the sign. This is a less than or equal to, this is a less than or equal to. So I knew that the positive 8 one was meant to go there. And now I solve, I subtract 4, and I get X has to be greater than -12. Or over here, subtract 4, X has to be less than positive 4. Sorry about that. 8 minus 4 is positive 4. So for my solution, I have X is greater than or equal to -12. And if I graph that, you'll see it's here with a closed circle, and where are the X values greater than -12? Well, that's this way. And for this one here, X has to be less than or equal to 4, so that's a closed circle here, and X values that are less are this way. So the way to rewrite this, the reason that they're saying this is an AND statement, is the X values have to be within this range here, this overlapping or intersection of values here. So X has to be in between what two values? Well, -12 and 4. And there's my solution. So the book likes to say, you know, when you start with a less than, you're going to end up with an AND statement, which is true here. See, we started with a less than, and we ended up with an AND statement. It likes to say that, look here, we have a greater than, it's going to be an OR statement, which again is exactly what we got here. Okay. The most important thing here is to remember that when you multiply or divide by a negative number, flip that inequality. And since we have to set the absolute value equal to the positive and the negative, make sure you flip that sign. So I said I was going to go a little out of order. I'm going to actually go to the next page, which would be 615. And I'm going to do these your turns. We'll start them off. So you're going to isolate your absolute value, and that's dividing by 3. X minus 7 is greater than or equal to 3. Now when you split this and you set it equal to -3, Well, we can't set it equal to because it's an inequality sign, so we have to remember to flip that sign. When we take the argument x minus 7 and we set it equal to the positive 3, we keep that sign because we didn't multiply by a negative, and you would go ahead and solve these. Same thing for number 10. Make sure that when you set it equal to that negative, you flip that inequality sign because you're multiplying by a negative. Now, jumping back to the first page of this module, I'm going to go to page 611. And it wants you to take all of these values and plug them in and see what you get. And you can go ahead and try that, but I want to look at the next page, which is on page 612. I want to look at what it means to solve the absolute value inequality graphically. So I'm looking at Explained 1 on page 612. And we're going to do what we did on the last lesson, where we graph this side and we graph this side and we see where this is true. So where is this function greater than this function here? So I'm going to use 2 different colors to graph these. So graphing the first side, it says the inequality of the form is in the form f of x is greater than g of x. So let's go ahead and graph this first one and see where that lies. And they already graphed it for us, which is nice. Our vertex is -3, 1, and that's where they graphed. Our amplitude was up 1 over 1, up 1 over 1, up 1 over 1, and they've got this nice perfect graph. For the other side, they have where y equals 4, and that's here. Just going to color code these so that we can clearly see this. And we're going back to the original where it says, where is the absolute value, where's the blue, if you will, greater than 4? So looking at these points of intersections, here and here, we're not just looking for where they intersect, but we're looking for where the blue is above or greater than. So for all these values that this would extend, right, that would actually be x is less than whatever value this is, which is -6. So if x is less than -6, the blue function is greater than. Okay? On this side, we have 0. So when x is greater than 0, right, that's when this is true. So we're looking for when this is true and when this is true. If it had said less than, then we would be looking below. Where is it below that y equals 4? But it's not, it's above. It's asking for where is it greater. So our solutions here are x is less than -6, or x has to be greater than 0. Okay, the next one, part B, we're going to do the same thing. We're going to graph it. Let's graph the absolute value here. So my vertex is 2, -3. 2, -3. My amplitude, my A in front, is 1, so I'm going to go up 1 over 1, up 1 over 1 in both directions. Sorry, my lines are not perfectly straight. And then 1. Where does y equal 1? Y equals 1 here. So the question here is, where is this red function less than 1? Well, if this is 1, right, this blue line is 1, less than 1 would be below. So we're just looking here. Okay, we don't want above that. So if I'm looking at this, it has to be between the values of, what is that, -2 and 6. And that's what we kind of have getting set up for us down here. So let's go through these. It says x has to be greater than negative 2, and x has to be less than 6. So this is from the graph